Our next one is y equals e raised to the x over 4, y equals 0, x equals 0, x equals 6, about the x-axis. Again, it's the x-axis, and the x-axis is horizontal. Since it's horizontal, we know that we are going to integrate with respect to x. Now we should graph this. Let's say that we don't know what y equals e raised to the x over 4 looks like. We can always stick that in the calculator just to get an idea. So if we want e raised to the x divided by 4, hit enter. We're looking at that type of exponential equation, an exponential that's growing. Coming over here, we're going to draw the other things first. Y equals 0, we know how to draw that. That's just the x-axis. X equals 0, we also know how to draw that. That's just going to be our y-axis. X equals 6 is a vertical line at 6. And then we know that our other function is just that exponential that's growing this way. And that's our y equals e raised to the x over 4. So the region that's bounded between all of those lines is this yellow region right here. And we are going to rotate that about the x-axis. Now, looking at this region, can we see our limits of integration? Do we know what the smallest yellow area is to the left and the largest yellow area is to the right? Yes, our bounds are easy to see here. It's from x equals 0 to x equals 6. So we can say that my volume is equal to pi times the integral from 0 to 6. And now I need to determine what is the radius. Well, remember the radius is always perpendicular to your axis of rotation. So in this case, my radius is going to be the blue line down to the orange line, which is e raised to the x over 4 minus the orange, which is 0. And I don't need that minus 0, so we're just going to say e raised to the x over 4. My radius is e raised to the x over 4 quantity squared dx. The first thing we need to do is square e to the x over 4. Well, when we have a power raised to a power, we multiply those exponents. So x over 4 times 2 is just x over 2, or 1/2 x. And then in order to integrate this, what we're going to need to do is to use a u sub. Well, if u is equal to the exponent 1/2 x, the derivative du would equal 1/2 dx. Well, I don't have a half dx, so I multiply both sides by 2, and 2 du is equal to dx. I'm going to rewrite us over here to the right-hand side. We say that our volume is equal to pi times the integral from x equals 0 to x equals 6, because I did not change my limits of integration, of e raised to the u and then 2 du. Well, the integral of e to the u is just e to the u, and again this gets evaluated from x equals 0 to x equals 6. Getting out of u's and back into x's, I have e raised to the 1/2 x, get evaluated from 0 to 6. Plugging in those limits of integration, plugging in a 6, e raised to the 1/2 times 6 is just going to be e to the 3rd. Plugging in a 0, e raised to the 1/2 times 0 is e to the 0, and that's just going to be 1. And so then my volume there is just 2 pi times e cubed minus 1. Let's look at number 4. Number 4 is y equals 5 minus x squared, y equals 4, x equals 0, about the line y equals 4. So we're going to be rotating this about the line y equals 4. Well, y equals 4 is horizontal. Since that's horizontal, we know that we are going to integrate with respect to x. Let's go ahead and graph the given so that we can find those limits of integration and we can find the radius. So I have y equals 5 minus x squared. I know how to graph that. That's just a parabola that opens down. We draw that parabola that opens down, and there we go. Then y equals 4. I know how to graph that. That is just a horizontal line. And lastly, I have x equals 0. Well, that's just the y-axis. So I can choose either side here. I'm going to choose the positive side and say that this side here is my region. It doesn't matter which side I choose because it's symmetric. So we're going to go ahead and choose the right hand side here because we're going to just take that and we are going to rotate this about y equal 4. So I'm looking at this and I need to figure out what my limits of integration are. Well, I can tell that one of them is 0. That's easy to see. But the other one I'm not sure about, but it is where the blue intersects the orange. So to find this point right here, I need to set those two equal to each other so that I can find what that value of x is. Where does 5 minus x squared equal 4? So where does blue equal orange? Subtract both sides by 5 and I have negative x squared is equal to negative 1. Divide by negative 1 and you get x squared is equal to positive 1. Taking the square root of both sides to solve this, and you get x is equal to plus or minus 1. Since we're looking at the right hand side, we know that we're looking at x equal 1. So this is where x is equal to 1. We have our limits of integration. Our volume is equal to pi times the integral from 0 to 1. And now I just need to figure out what my radius is. I'm going to make this just a little bit larger. Remember, your radius is always perpendicular to your axis of rotation. This right here is my radius. It is the distance from the curve to the axis of rotation. So what would the radius be in this case? Well, the radius is going to be the curve, which is the blue thing, which is 5 minus x squared, minus all the way down to the orange thing, which is 4. So my radius in this case was 5 minus x squared minus 4. If I clean that up, my radius is going to be 1 minus x squared. My radius in this case was 1 minus x squared because it's the distance from the curve to the axis of rotation. So I'm going to square 1 minus x squared to find this volume. If I'm squaring this, again, write it twice in FOIL if you need to so you don't make a mistake. And you end up with 1 minus x squared minus another x squared is minus 2x squared. And then finally plus x to the 4th. Integrating this, we get x minus 2x cubed over 3 plus x to the 5th over 5. And that gets evaluated from 0 to 1. Plugging in the limits of integration, and you get 1 minus 2 times 1 cubed over 3 plus 1 to the 5th over 5. And then minus, well, if I plug 0 in each one of those terms, they're just going to be 0, so it's just minus 0. So you only need to worry about putting that part into a calculator to find the answer. And since it's a 1, we really just need to figure out what's 1 minus 2/3 plus 1/5. So on a calculator, 1 minus 2/3 plus 1/5, and then make it into a fraction. So hit math and then enter twice. And you get 8 over 15. Therefore, my volume here is 8 pi over 15. Let's look at number 5. Number 5 is y equals 2x squared, x equal 2, y equals 0, and we're going to be rotating this about the line x equal 2. Well, the line x equal 2 is vertical. Since this is vertical, I know that I need to integrate with respect to y. So let's go ahead and graph all the given here. I know that I have y equals 2x squared. I know that I have x equal 2. And I know that I have y equals 0. Well, y equals 0 is the easy one. That's just the x-axis. X equal 2 is just going to be a vertical line at 2. And then the other one over here, y equals 2x squared, well, that's just a parabola that opens up. Also, when x is equal to 2, plugging in a 2 in place of that x, that's 2 times 2 squared, y is going to equal 8. So I'm just going to go all the way to 8 on my y-axis. So at 0, I'm at 0, at 1, I'm at 2, and at 2, I'm all the way to 8. And I'm only going to draw this side of the parabola because the region that's bounded by x equal 2, y equals 0, and y equals 2x squared is that region right there. I need to integrate with respect to y, not with respect to x. Can I easily see the limits of integration in y? Yes, but that's because we drew it really well. If not, it would be wherever blue intersects orange. Well, if we want to know where blue intersects orange, we would just say y equals 2 times 2 squared, which is that y equal 8 that we did before. So I can see the limits of integration. The limits of integration there are from 0 to 8. Now I need the radius. The radius is always perpendicular to the axis of rotation. This is my radius right here. Well, what is that radius? Well, first thing is that it needs to be integrating with respect to y, and this is not a function of y yet. So the first thing we want to do is take our given and solve it for x so that we have a function of y. If I solve this for x, divide both sides by 2 first, and then you take the square root of both sides and you get plus or minus the square root of y over 2 is equal to x. Two separate equations, x equals positive square root of y over 2 and x equals negative square root of y over 2. Well, since we're on the positive side of my x-axis, it's not this guy, it's this guy right here. My radius has to be this right curve minus this left curve, so in this case it's going to be 2, because this is x equal 2, minus the square root of y over 2. That radius is, again, right minus left, because to the right you're bigger than to the left in terms of your curves. Right minus left from 2 all the way back to the square root of y over 2. So I take 2 minus the square root of y over 2 and I square it. Well, if you write that twice to make sure you don't make a mistake when you FOIL, you end up with, well, 2 times 2 is 4 minus 2 square roots of y over 2 minus another 2 square roots of y over 2 is minus 4 square roots of y over 2. And then the square root of y over 2 times the square root of y over 2, and that's just going to be plus y over 2. So I'm going to rewrite this without the radical so that it's easier for us to integrate. And also notice that the denominator here is just the square root of 2, so that's a number, and that makes it a constant multiplier, so I don't need to keep it with my y. We say volume equals pi times the integral from 0 to 8 of 4 minus 4 over the square root of 2 times y raised to the 1/2, and then plus, we'll call this 1/2 y. Now let's integrate. The integral of 4 is 4y. 4 over the square root of 2 is a constant multiplier that multiplies along. We add 1 to 1/2. Since that's a fraction, instead of dividing by 3/2, we're going to go ahead and multiply by the reciprocal of 3/2, which is 2/3. And then here I'm going to be dividing by 2, so that makes it just 1/4 y squared. And this gets evaluated from 0 to 8. Cleaning this up before we stick it in the calculator, we have 4y minus 8 over 3 square roots of 2, y to the 3/2, plus, we'll just say y squared over 4 here, evaluated from 0 to 8. Plugging in those limits of integration, we have 4 times 8 minus 8 over 3 square roots of 2 times 8 raised to the 3/2 plus 8 squared over 4. And then minus, if I plug in a 0 and all these y's, that's just going to be a 0. So let's put that into a calculator. We have 4 times 8, and then minus, and I'll do alpha y equals for a numerator and denominator, and that's going to be 8 over 3 times the square root of 2, and then that's going to be multiplied by 8 raised to the 3/2 power. And then finally, plus alpha y equals for a numerator and denominator, 8 squared divided by 4. Hit enter and make that into a fraction, and you get 16 over 3. So your volume here is just 16 pi over 3.